Question 1. Fill in the blanks by selecting the correct options from the drop-down menus. To provision Azure AI services, you can use the Azure portal, or automate deployment using Bicep or ARM templates. I'll explain these answers now, after going through the question and correct options. To begin with, Azure Portal is correct because it gives you a graphical interface where you can create and configure Azure resources step by step, which is a common way teams provision Azure AI services quickly. Furthermore, Bicep or ARM templates are correct because they let you define infrastructure as code, so you can deploy the same Azure AI resources repeatedly and consistently, for example, when setting up identical environments for development, testing, and production. In contrast, GitHub Copilot helps you write code, but it doesn't provision Azure infrastructure by itself. Likewise, Docker Compose focuses on running multi-container apps and isn't used to create Azure AI resources in Azure. Finally, REST routing is about how APIs communicate, not about deploying the underlying Azure services. Question 2. For each Azure AI Foundry element, drag it to the appropriate box in the correct match column to match it against its universally true description in the option column. Each item may be used once, more than once, or not at all, associated with an Azure AI Foundry resource in an Azure subscription. Correct match is Foundry projects. Associated with an Azure AI Hub resource in an Azure subscription. Correct match is Hub-based projects, web-based visual interface for working with AI projects. Correct match is Azure AI Foundry portal, programmatic toolkit used to build AI solutions. Correct match is Azure AI Foundry SDK. I'll explain these matches now, after reading through each description and its correct match. To begin with, Foundry projects align with an Azure AI Foundry resource because they are created directly under that resource, providing the main structure for organizing AI workloads within a subscription. Next, Hub-based projects correctly align with an Azure AI Hub resource, since they rely on the Hub for shared configuration, governance, and collaboration across multiple projects. Moving forward, Azure AI Foundry portal fits the web-based visual interface description because it is the browser-based environment used to manage AI projects, resources, and deployments visually. Finally, Azure AI Foundry SDK matches the programmatic toolkit description because it allows developers to build and manage AI solutions through code, which is essential for automation and real-world application development. Question 3. Fill in the blanks by selecting the correct options from the drop-down menus. Azure AI Hub resources support advanced development scenarios, such as building prompt flow, applications, and performing model fine-tuning. I'll explain these answers now after going through the question and the correct options. To begin with, prompt flow is correct because Azure AI Hub resources are designed to support prompt-based workflows, which allow developers to design, test, and orchestrate complex AI interactions in a structured way, similar to building end-to-end AI pipelines in real projects. Furthermore, fine-tuning is correct because Hub resources enable model customization, allowing you to adapt pre-built models to specific business needs, such as training a model on company-specific documents or domain-specific data. In contrast, content filtering focuses on safety controls rather than advanced development workflows. Likewise, Canary Release relates to deployment strategies and not to building or training AI models. Finally, container scanning and feature flags are operational and security features, not capabilities used for prompt flow development or model fine-tuning within Azure AI Hub resources. Question 4. For each statement below, indicate whether the answer is true or false. Azure AI Search can serve as a retriever in an Azure AI Foundry chat flow. True. A text-based index is always superior to a vector index for semantic retrieval tasks. False. Embeddings enable retrieval of semantically related content even when wording differs. True. Creating a vector search index requires generating embeddings with an embedding model available in Azure AI Foundry. True. I'll explain these answers now after going through the statements and their correct responses. To begin with, the first statement is true because Azure AI Search integrates directly with Azure AI Foundry and can be used as a retriever to pull relevant context into chat flows, which is common in real-world RAG scenarios. However, the second statement is false because vector indexes are generally better for semantic retrieval since they compare meaning rather than exact keyword matches, making them more effective for understanding user intent. Next, the third statement is true because embeddings convert text into numerical representations, allowing systems to recognize similar meanings even when different words or phrasing are used. Finally, the fourth statement is true because vector search depends on embeddings, and Azure AI Foundry provides embedding models that are used to generate those vectors before creating a vector search index. Question 5. For each stage in a responsible generative AI plan, drag it to its correct, universally true description. Each item may be used once, more than once, or not at all. Identify relevant risks the solution might cause. Correct match is map. Evaluate outputs to determine whether defined risks occur. Correct match is measure. Reduce risks through layered controls and communicate transparently to users. Correct match is mitigate. Establish deployment and operational practices to sustain responsible use. Correct match is manage. I'll explain these matches now after going through each stage and its correct description. To begin with, map is correct because this stage focuses on identifying potential harms and risks early, so teams clearly understand what issues to watch for before the system is deployed. Next, measure fits the evaluation description because it involves testing and monitoring system outputs to check whether the risks identified during mapping are actually occurring. Moving forward, mitigate is correct because this stage applies layered safeguards across data, models, systems, and user experience, while also communicating remaining risks clearly to users. Finally, manage is the correct match for sustaining responsible use, because it covers deployment, monitoring, and operational practices that ensure the system continues to run responsibly over time. Question 6. A financial analytics company needs to build a forecasting solution using generative AI. They require a model specifically optimized for time series predictions rather than open-ended text generation. Select one answer. A. Select GPT-4o to process visual data and generate reports on chart images. B. Use Nixla TimeGen 1, which is specialized for time series forecasting and predictive analytics. C. Choose DALL-E 3 to generate visual forecasts of financial graphs. D. Deploy an embedding model like Ada for semantic similarity searches. The correct answer is B. Use Nixla TimeGen 1, which is specialized for time series forecasting and predictive analytics. Now, let's break down why that choice fits best. To begin with, Nixla TimeGen 1 is designed specifically for time series prediction, meaning it focuses on forecasting future numerical values from historical patterns, exactly what financial analytics teams need for trend prediction and predictive reporting. In contrast, GPT-4o can interpret and generate text and can work with images, but it is not tuned as a dedicated numerical forecasting engine for time series prediction tasks. Similarly, DALL-E 3 generates images, so even if it can create a graph-like picture, it is not a forecasting model that predicts future values from data. Finally, an embedding model like Ada is used to convert text into vectors for search and similarity, which helps retrieval scenarios, not time series forecasting. Question 7. A team is building a Python app that must programmatically access an Azure AI project, send prompts to a model available in that project, and process responses. They plan to run the app locally during development. Which two actions are necessary to enable authenticated access from code? Select two answers. A. Set the Azure region to any value without providing the project endpoint. B. Install the Azure AI projects package using pip. C. Replace default Azure credential with a hard-coded API key for all calls. D. Run AZ login or otherwise ensure an authenticated Azure session before executing the code. The correct answers are B. Install the Azure AI Projects package using pip, and D. Run AZ login or otherwise ensure an authenticated Azure session before executing the code. Now that we've reviewed every option, let's walk through the reasoning step by step. To start with, installing the Azure AI Projects package is essential because it provides the Python SDK that enables direct programmatic interaction with Azure AI projects and their models. Next, running AZ login is required during local development because the SDK typically uses default Azure credential, which depends on an active signed-in Azure session to authenticate requests securely. By contrast, simply setting an Azure region without specifying the project endpoint does not grant access to a specific Azure AI project, so that option does not meet the requirement. Finally, hard coding an API key in place of default Azure credential is unnecessary for this scenario and goes against recommended security practices, especially when secure, built-in authentication is already supported. Question 8. Which statements accurately describe embeddings and cosine similarity in vector search? Select two answers. A. Embeddings are vectors of floating point numbers representing text meaning. B. Cosine similarity measures the cosine of the angle between vectors to estimate semantic similarity. C. Embeddings must be identical strings to match results. D. Cosine similarity returns exact keyword matches only. The correct answers are A. Embeddings are vectors of floating point numbers representing text meaning, and B. Cosine similarity measures the cosine of the angle between vectors to estimate semantic similarity. After reviewing all the options, here's how they fit together conceptually. To begin with, embeddings convert text into numerical vectors that capture semantic meaning, which allows systems to compare concepts rather than just exact words. Next, cosine similarity works by comparing the angle between two vectors, so texts with similar meanings end up closer together in vector space, even if the wording is different. By contrast, embeddings do not require identical strings to match, because similarity is based on numerical distance, not text equality. Likewise, cosine similarity does not return exact keyword matches only, since it evaluates vector orientation to estimate semantic closeness, rather than relying on keyword overlap alone. Question 9. Arrange the following steps to prepare data for hybrid or vector retrieval in an Azure AI Foundry project. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Add your data to Azure AI Foundry. Create an Azure AI search index using an embedding model. Query the Azure AI search index from your chat flow to retrieve grounding context. With the sequence laid out, let's walk through why this order matters. To begin with, data must first be added to Azure AI Foundry because retrieval cannot happen unless the project actually contains source content to work with. Next, once the data is in place, an Azure AI search index is created using an embedding model so the content can be converted into vectors and made searchable using semantic or hybrid retrieval techniques. Finally, the chat flow queries the Azure AI search index, which allows the model to pull precise and semantically relevant grounding context at runtime, improving the accuracy and reliability of generated responses. Question 10. For each statement below, indicate whether the answer is true or false. Prompt flow orchestrates a series of connected tools to process inputs and produce outputs. True. The index lookup tool is optional when implementing RAG because retrieval is handled implicitly by the LLM node. False. Prompt variants can influence groundedness by instructing the model to use retrieved context and be factual. True. After configuring and testing the chat flow, it can be deployed and integrated into an application for an agentic experience. True. With the answers clearly stated, let's connect each one to how prompt flow works in practice. To start with, the first statement is true because prompt flow is designed to orchestrate multiple connected components, such as inputs, tools, and models, into a single workflow that transforms inputs into outputs. However, the second statement is false because retrieval in a RAG setup is not automatic. The index lookup tool must be explicitly included to fetch documents, since the LLM node alone does not retrieve external data. Next, the third statement is true because prompt variants and system instructions can guide the model to rely on retrieved context, improving groundedness and reducing hallucinations. Finally, the last statement is true because once a chat flow is configured and validated, it can be deployed and integrated into an application, enabling agent-like behavior that responds dynamically to user interactions. Question 11. You are tasked with building a multilingual chatbot that must analyze customer messages for sentiment, provide translations across many languages, and sometimes answer questions based on a company knowledge base. Which two Azure AI services should you integrate? Select two answers. A. Azure AI Translator. B. Azure AI Speech. C. Azure AI Language. D. Azure AI Custom Vision. The correct answers are A. Azure AI Translator, and C. Azure AI Language. Now that all options are on the table, let's walk through why these two are the right fit. To begin with, Azure AI Translator is essential because it enables multilingual text translation, allowing the chatbot to understand and respond to users across different languages without rebuilding logic for each one. Next, Azure AI Language is a key component because it provides sentiment analysis, entity recognition, summarization, and conversational question answering, which directly supports understanding customer messages and answering questions from a knowledge base. By contrast, Azure AI Speech focuses on audio scenarios like speech-to-text and text-to-speech, which are not required when the chatbot is processing text messages. Finally, Azure AI Custom Vision is designed for image classification and detection, making it irrelevant for a text-based, multilingual chatbot focused on sentiment, translation, and question answering. Question 12. Which statement accurately describes the composition of a hub-based project? Select one answer. A. It excludes Foundry resources and only uses Azure Machine Learning assets. B. It includes an Azure AI Foundry resource along with managed compute and connected storage or Key Vault. C. It replaces Foundry projects entirely and cannot interoperate with them. D. It provides prompt flow but cannot integrate with Azure Machine Learning. The correct answer is B. It includes an Azure AI Foundry resource along with managed compute and connected storage or Key Vault. Now that all the options have been read, let's break down why this one is correct. To begin with, a hub-based project is designed to bundle an Azure AI Foundry resource together with supporting infrastructure, such as managed compute and integrated storage or Key Vault, which enables more advanced and scalable AI development scenarios. By contrast, excluding Foundry resources entirely is incorrect because the hub is built around a Foundry resource, not separate from it. Likewise, hub-based projects do not replace Foundry projects. Instead, they complement and interoperate with them to support broader workflows and shared resources. Finally, while prompt flow is supported, hub-based projects can integrate with Azure Machine Learning, making it incorrect to suggest that such integration is not possible. Question 13. You're auditing an AI project to inventory only its Azure OpenAI connections from Python. You want a concise list and to avoid handling unrelated connection types. Which two actions are appropriate? Select two answers. A. Call projectclient.connections.list with the connection type parameter set to Azure OpenAI. B. Use projectclient.connections.get with a specific connection name to list all connections. C. Iterate the returned collection and print connection.name and connection.type. D. Omit the connection type parameter and rely on client-side string matching. The correct answers are A. Call projectclient.connections.list with the connection type parameter set to Azure OpenAI, and C. Iterate the returned collection and print connection.name and connection.type. With every option considered, here's why these two work together effectively. To begin with, using the list method with the connection type parameter applies server-side filtering. which returns only Azure OpenAI connections and avoids pulling in unrelated connection types. Next, iterating over the returned collection and printing each connection's name and type gives you a clean, readable inventory that clearly shows what Azure OpenAI connections exist in the project. By contrast, calling get with a specific connection name retrieves only one connection, not a full inventory, so it does not meet the requirement. Likewise, omitting the connection type parameter and filtering on the client side is inefficient and unnecessary when the SDK already supports precise filtering at the source. Question 14. Fill in the blanks by selecting the correct options from the drop-down menus. AI agents are software services that use generative AI to perform tasks on behalf of a user or another program. With the completed statement in view, let's clarify why each selection fits naturally. To begin with, AI agents are described as software services because they are implemented as software components that run logic, call tools, and interact with systems rather than acting as physical or infrastructure resources. Next, generative AI is correct because agents rely on generative models to understand input, reason about actions, and generate responses or decisions dynamically. Finally, acting on behalf of a user or another program reflects the core purpose of an AI agent, which is to autonomously carry out tasks for humans or other software systems, rather than operating in isolation. Question 15. For each statement below, indicate whether the answer is true or false. Dynamic tool discovery lets an AI agent find available external tools at runtime without hard-coding each one. True. The addmcp.tool decorator is used to expose server functions as tools. Dynamic tool discovery guarantees that agents never need any updates for any reason. False. Centralized discovery is especially useful where tools evolve rapidly or many teams manage different services. True. With the outcome stated, let's connect the ideas behind each one. To begin with, the first statement is true because dynamic tool discovery allows an agent to query a central catalog at runtime, removing the need to manually register or hardcode every available tool. Next, the second statement is also true since the @mcp.tool decorator explicitly marks server-side functions so they appear as callable tools that clients and agents can discover and use. However, the third statement is false because while dynamic discovery reduces redeployment when tools change, agents may still require updates for other reasons such as logic changes, security updates, or new capabilities. Finally, the last statement is true because centralized discovery becomes highly valuable in environments where APIs change frequently or where multiple teams independently manage different services, ensuring agents always see the latest tool definitions. Question 16. Fill in the blanks by selecting the correct options from the drop-down menus. The Microsoft Agent Framework allows developers to integrate AI models into applications using an open-source SDK, while the Azure AI Foundry Agent Service provides a fully managed platform for building and scaling enterprise-grade AI agents. With the completed statement in front of us, let's unpack how each part fits together. To begin with, AI models is correct because the Microsoft Agent Framework is designed to help developers embed large language models and related AI capabilities directly into their applications. Next, open source SDK is the right choice because the framework is openly available, allowing developers to extend, customize, and integrate agent capabilities through familiar development workflows. Finally, fully managed platform accurately describes the Azure AI Foundry Agent Service, since it handles infrastructure concerns like scaling, availability, and operations automatically, making it suitable for enterprise-grade agent deployments without managing underlying compute or storage. Question 17. For each built-in tool, drag it to the correct description in the correct match column. Each item may be used once, more than once, or not at all. Executes Python code for calculations and data analysis. Code interpreter. Searches through and analyzes documents. File search. Retrieves information from the internet. Web search. With the matches clearly stated, let's make sense of how each tool is used in practice. To begin with, Code Interpreter fits the first description because it runs Python code, allowing an agent to perform calculations, transform data, or analyze datasets as part of solving a task. Next, File Search matches the document analysis description, since it is designed to scan, search, and extract relevant information from uploaded or connected documents. Finally, Web Search aligns with retrieving information from the internet because it enables the agent to look up current or external information from public web sources when responding. As a result, tools like Image Generator and Email Sender remain unused here, since they do not correspond to any of the listed descriptions. Question 18. For each statement below, indicate whether it is true or false. Agents can be discovered automatically once their agent card is published. The discovery process requires manual input from the routing agent each time. False. Publishing the agent card enables visibility to other agents in the network. True. Discovery must occur before requests can be routed to the agent's skills. True. Kita? With those determinations made, let's connect the reasoning behind each one. To begin with, the first statement is true, because publishing an agent card makes the agent automatically discoverable, allowing other agents in the system to find and collaborate with it without additional configuration. In contrast, the second statement is false, since discovery is handled automatically by the system and does not require repeated manual input from a routing agent. Moving on, the third statement is true because the agent card exposes the agent's metadata, which is what enables visibility and discoverability across the agent network. Finally, the fourth statement is true because discovery must logically happen before routing, ensuring the routing agent knows which agents exist and what skills they can handle before sending requests. Question 19. A developer is building an agent that needs to ground prompts with Fabric data stores and call external APIs. Which tool configuration should they use? Select one answer. A. Bing Search plus File Search. B. Microsoft Fabric plus OpenAPI Spec. C. Azure Functions plus Custom Functions. D. Code Interpreter only. The correct answer is B. Microsoft Fabric plus OpenAPI Spec. With all options reviewed, here's why this configuration is the right choice. To begin with, Microsoft Fabric provides direct grounding from Fabric data stores, allowing the agent to retrieve enterprise data as contextual input for its prompts. In addition, OpenAPI Spec enables the agent to call external APIs in a structured and standardized way, which is exactly what's needed when integrating third-party or internal services. By contrast, Bing Search and File Search focus on web and document data and do not provide access to Fabric data stores or external APIs. Similarly, Azure Functions and Custom Functions execute code but do not inherently ground prompts with Fabric data or define API contracts for agent calls. Finally, using Code Interpreter alone limits the agent to local Python execution and does not support direct API calls or Fabric data grounding in this context. Question 20. An IT department develops a custom tool for its agent to integrate with the ticketing and knowledge base system. The agent can troubleshoot common technical issues, escalate more complex ones, and track ticket statuses. What outcomes should the organization expect from this setup? Select one answer. A. Greater dependency on manual ticket processing for every issue. B. Lower productivity because the agent ignores ticket statuses. C. Increased delays because the agent cannot escalate issues. D. Faster resolution of issues, reduced downtime, and higher employee productivity. The correct answer is D. Faster resolution of issues, reduced downtime, and higher employee productivity. With all options considered, here's why this outcome makes sense. To begin with, integrating the agent with ticketing and knowledge-based systems allows it to resolve common issues automatically, which significantly reduces the time users spend waiting for support. In addition, the ability to escalate complex issues ensures that problems beyond the agent's scope are quickly handed off to human specialists, preventing bottlenecks. At the same time, tracking ticket statuses keeps users informed and reduces follow-up queries, which improves overall productivity across the organization. By contrast, the other options describe outcomes that directly contradict the agent's capabilities, since automation, escalation, and tracking are specifically designed to reduce manual work, delays, and productivity losses. Question 21. For each statement below, indicate whether the answer is true or false. The Microsoft Agent Framework combines large language models with traditional programming logic. True. Developers can switch orchestration patterns in the framework without rewriting agent logic. True. The base chat client abstraction supports integration with multiple AI service providers. True. Agents built with the framework cannot invoke external APIs. False. With the answers laid out, let's connect each one to how the framework works in real scenarios. To begin with, the first statement is true because the Microsoft Agent Framework is designed to blend LLM reasoning with standard programming logic, enabling agents to make decisions and take actions programmatically. Next, the second statement is also true, since the framework separates orchestration from agent logic, allowing developers to change orchestration patterns without rewriting the core agent behavior. Moving on, the third statement is true because the base chat client abstraction provides a consistent interface that works across multiple AI providers, such as Azure OpenAI and others. Finally, the last statement is false because agents built with the framework can call external APIs through integrated tools and functions, which is essential for real-world automation and system integration. And I correct us. Question 22. Arrange the main implementation stages for handoff orchestration in the correct sequence. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Set up data models and chat client. Create specialized executor functions. Build routing logic. Assemble the workflow. Now that the order is clear, here's how the sequence fits together in a real build. To begin with, you start by setting up data models and the chat client, because that establishes the shared structure for messages, state, and how agents communicate. Next, you create specialized executor functions, because those define how specific tasks are carried out when a handoff happens, such as running a particular agent's capability or toolchain. After that, you build routing logic to decide when control should move from one agent to another based on intent, conditions, or intermediate results. Finally, you assemble the workflow by wiring the models, executors, and routing together into one cohesive orchestration pipeline that can run end-to-end. Question 23. A multi-agent solution uses several domain-specific agents for analysis, planning, and execution. The system continuously shares context among agents, while the Magentic Manager assigns actions based on each agent's capabilities. What fundamental advantage does this approach provide? Select one answer. A. Predetermined fixed task sequence that ignores feedback. B. Manual synchronization of agent messages. C. Independent agent operation without coordination. D. Dynamic collaboration where each agent contributes specialized expertise toward a shared evolving solution. The correct answer is D. Dynamic collaboration where each agent contributes specialized expertise toward a shared evolving solution. With all options reviewed, here's why this advantage stands out. To begin with, sharing context continuously allows agents to stay aligned on goals and progress, which enables them to build on each other's outputs rather than working in isolation. At the same time, the Magentic Manager assigns tasks based on each agent's strengths, ensuring that analysis, planning, and execution are handled by the most suitable agent at every stage. As a result, the system adapts dynamically as new information emerges, refining the solution collaboratively instead of following a rigid, predefined sequence. By contrast, the other options describe static, manual, or uncoordinated behaviors that eliminate the core benefit of multi-agent orchestration, which is coordinated, context-aware collaboration toward a shared outcome. Question 24. Which two statements accurately describe registering MCP-discovered tools with an agent? Select two answers. A. Session.list tools is used to execute tools directly without wrappers. B. The client wraps each tool in an async function that internally uses session.callTool. C. Wrapped tool functions are bundled into function tool objects and then registered to the agent's toolset. D. FastMCP on the server is responsible for registering the tools with the agent. The correct answers are B. The client wraps each tool in an async function that internally uses session.callTool. And C. Wrap tool functions are bundled into function tool objects and then registered to the agent's toolset. With all options considered, here's how the registration flow works in practice. To begin with, tools discovered through MCP are not executed directly. Instead, the client creates asynchronous wrapper functions that call session.callTool, which ensures proper invocation and response handling. Next, those wrapper functions are packaged into function tool objects and registered with the agent, making them available to the agent at runtime just like native tools. By contrast, session.list tools is used only to discover available tools, not to execute them directly. Likewise, FastMCP on the server exposes tools for discovery, but the responsibility for wrapping and registering them with the agent lies on the client side, not the server. Question 25. What is a primary enterprise advantage of using Azure AI Foundry Agent Service? Select one answer. A. It is only suitable for small-scale development environments. B. It limits developers to a single provider for AI integration. C. It requires manual setup of all infrastructure before deployment. D. It enables developers to build, deploy, and scale extensible AI agents without managing compute or storage resources. The correct answer is D. It enables developers to build, deploy, and scale extensible AI agents without managing compute or storage resources. With every option considered, here's why this advantage matters at enterprise scale. To begin with, Azure AI Foundry Agent Service is fully managed, which means teams can focus on agent logic and business value, while the platform automatically handles infrastructure, scaling, and operations. As a result, organizations can deploy agents faster and scale them reliably without provisioning or maintaining compute or storage themselves. By contrast, the other options describe limitations that directly contradict the service's purpose, since it is designed for enterprise-scale use, supports flexible integrations, and removes the burden of manual infrastructure management. Question 26. Which endpoint path is typically used to expose an agent's capabilities for discovery by clients and other agents? Select one answer. A. Well-known agentcard.json. B. agentexecutortask.json. C. API/discover-agent. D. tasks-store-metadata.json. The correct answer is A. Well-known agentcard.json. With all options reviewed, here's why this endpoint is the correct choice. To begin with, /well-known agentcard.json is the standardized discovery endpoint used to publicly expose an agent's metadata, including its capabilities, skills, and communication details, so that clients and other agents can discover and interact with it. By contrast, the other paths suggest internal execution, task handling, or hypothetical discovery mechanisms, none of which are defined as the standard endpoint for agent capability discovery. Question 27. Which statement correctly describes the role of the agent card in client-agent communication? Select one answer. A. It defines the client's available connection methods. B. It provides metadata and endpoint details for the agent. C. It handles streaming message delivery between the client and server. D. It stores task results for long-running operations. The correct answer is B. It provides metadata and endpoint details for the agent. With all options reviewed, here's why this description is accurate. To begin with, the agent card acts as a discovery and description document that exposes the agent's capabilities, supported operations, and endpoint information, which clients rely on to know how and where to communicate with the agent. By contrast, connection behavior and streaming mechanics are handled by the client and transport layers, not by the agent card itself. Likewise, long-running task storage is managed by execution or persistence components, not by the agent card, which focuses purely on describing the agent rather than operating it. Question 28. Fill in the blanks by selecting the correct options from the drop-down menus. Azure AI Language Question Answering enables developers to define a knowledge base of question and answer pairs that can be queried through natural language input. With the full statement in place, let's clarify what each part means in practice. To begin with, a knowledge base is the core structure used by Azure AI Language Question Answering because it stores and organizes all the information the service can respond with. Next, defining that knowledge base as a collection of question and answer pairs is essential, since each pair maps a user's question to a precise expected response, enabling accurate and consistent answers. As a result, when users ask questions in natural language, the service can match their intent against these predefined pairs and return the most relevant answer efficiently. Question 29. For each stage of managing a question-answering knowledge base, drag the correct description to the correct match column. Each item may be used once, more than once, or not at all, adjusting the model to improve accuracy before release. Training. Submitting queries interactively and reviewing responses. Testing. Making the knowledge base available through a REST endpoint. Deployment. With the matches established, let's walk through what each stage represents in practice. To begin with, training is the stage where the model is refined so it can better understand user intent and accurately match questions to the most appropriate answers before the knowledge base goes live. Next, testing involves interactively asking questions and reviewing the returned answers and confidence scores, which helps validate quality and identify gaps or mismatches. Finally, deployment is the step where the knowledge base is published to a REST endpoint, allowing applications, bots, or services to query it programmatically in real-world scenarios. Question 30. For each Azure AI translator capability, drag it to its correct description. Each item may be used once, more than once, or not at all. Identifies the language in which text is written. Language detection. Converts text from one alphabet or writing system to another. Script transliteration. Translates text from one language into multiple target languages. One-to-many translation. With the matches in place, let's see how each capability is used in real scenarios. To begin with, language detection determines the original language of the input text, which is especially useful when users submit content without specifying the language beforehand. Next, script transliteration converts text between writing systems, such as transforming Cyrillic characters into Latin characters, while keeping the original language intact. Finally, one-to-many translation allows a single source text to be translated into several target languages at once, making it ideal for multilingual communication and global content distribution. Question 31. Fill in the blanks by selecting the correct options from the drop-down menus. The Python Speech SDK can be installed using the command pip install Azure Cognitive Services-speech, and developers typically create a speech config object to connect to the speech service using a key and region. With the completed statement in view, here's how each part fits into real development work. To begin with, pip install Azure Cognitive Services-speech is the correct command because it installs the official Azure Speech SDK package required to work with speech-to-text, text-to-speech, and other speech service features in Python. Next, speech config is the correct object because it holds the authentication and configuration details, such as the subscription key and Azure region, that allow the SDK to securely connect to the Azure Speech service. Together, these steps form the standard starting point for building Python applications that integrate Azure speech capabilities reliably and correctly. Question 32. For each statement below, indicate whether it is true or false. A single SSML document can switch between multiple voices. Prosody controls include pitch, timbre, and speaking rate. True. Say-as rules are intended to alter audio encoding parameters. False. Inserting recorded audio can be used to include background sound within synthesized speech. True. With the answers identified, let's walk through what each one means in practice. To begin with, the first statement is true because SSML allows multiple voice elements in a single document, enabling different parts of the output to be spoken by different voices. Next, the second statement is also true, since prosody controls directly affect how speech sounds, including pitch, timbre, and speaking rate, which shape the naturalness and style of delivery. However, the third statement is false because say-as rules control how text is interpreted and spoken, such as reading dates or phone numbers correctly, not how audio is encoded. Finally, the fourth statement is true because SSML supports embedding recorded audio, which makes it possible to add background sounds or audio cues alongside synthesized speech. Question 33. Arrange the following steps involved in defining a multi-turn conversation in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Import or define initial question-answer pairs. Add a follow-up prompt to collect clarifying information. Link the follow-up prompt to an existing or new answer. Apply context restriction if the answer should appear only within this dialogue. With the sequence set, let's see how these steps work together in practice. To begin with, you start by importing or defining the initial question-answer pairs because they establish the base knowledge and entry points for the conversation. Next, you add a follow-up prompt to gather clarifying information, allowing the conversation to continue dynamically based on the user's response. After that, the follow-up prompt is linked to an existing or newly created answer, ensuring the system knows how to respond once the additional information is provided. Finally, context restriction is applied so that the answer appears only within this specific dialogue, preventing it from being triggered in unrelated conversations and keeping the interaction coherent. Question 34. For each statement below, indicate whether it is true or false. You can test your knowledge base directly in Language Studio by submitting questions. True. Testing displays confidence scores and alternative answers. True. Deploying a knowledge base automatically improves its training performance. False. After deployment, applications can access the knowledge base through a REST endpoint. True. With the results clear, here's how each statement aligns with how question answering works. To begin with, the first statement is true because Language Studio provides an interactive test interface where you can submit questions and immediately see how the knowledge base responds. Next, the second statement is also true since testing surfaces confidence scores and possible alternative answers, which helps evaluate answer quality and accuracy. However, the third statement is false because deployment only publishes the knowledge base. Improving training performance requires separate training and refinement steps. Finally, the fourth statement is true because once deployed, the knowledge base is exposed through a REST endpoint that applications and bots can call programmatically. Question 35. A developer trained a custom classification model for game summaries using Azure AI language. During evaluation, the results show that adventure and strategy labels are often confused. What should the developer do next to improve the model's performance? Select one answer. A. Add more high-quality examples for both adventure and strategy categories. B. Deploy the model immediately since the overall accuracy is high. C. Delete existing training data to simplify classification. D. Reduce the number of labels to 1 to minimize confusion. The correct answer is A. add more high-quality examples for both adventure and strategy categories. With the options reviewed, here's why this is the right next step. To begin with, confusion between two labels usually means the model has not seen enough clear, representative examples to distinguish them properly. By adding more high-quality and diverse training samples for both adventure and strategy, the model learns sharper boundaries between the categories, which improves precision and reduces misclassification. In contrast, deploying the model immediately would lock in the current weaknesses instead of fixing them. Likewise, deleting training data would reduce learning signals and harm performance rather than improve it. Finally, collapsing everything into a single label removes meaningful distinctions instead of solving the underlying classification problem. Question 36. A data scientist trains a text classification model through the REST API. After sending the training request, they receive a response containing a location header. What should be done next? Select one answer. A. Use the same URL to deploy the model without checking status. B. Resubmit the training request immediately. C. Use the location URL to poll the training status until it shows succeeded. D. Ignore the header and check the Azure portal manually. The correct answer is C. Use the location URL to poll the training status until it shows succeeded. With all options reviewed, here's why this is the correct workflow. To begin with, training requests are handled asynchronously, so the initial response does not mean the model is ready. The location header provides a status endpoint that must be polled to track progress and confirm when training has successfully completed. In contrast, resubmitting the request would duplicate the job and waste resources. Likewise, deploying immediately without checking status risks deploying an incomplete or failed model. Finally, while the Azure portal can show status, the REST-based workflow is designed to use the location URL directly for programmatic monitoring and control. Question 37. For each statement below, indicate whether it is true or false. Precision and recall are the only two metrics used to evaluate model performance. False. The F1 score combines precision and recall into a single value. True. A high recall but low precision means the model detects many entities but mislabels them. True. The confusion matrix visually shows where the model performs well and where it struggles. True. With the answers identified, let's connect each one to model evaluation in practice. To begin with, the first statement is false because precision and recall are important, but they are not the only metrics used. Measures like F1 score and confusion matrices also play a key role in understanding performance. Next, the second statement is true since the F1 score balances precision and recall into a single value, making it useful when you need a unified view of model accuracy. Moving on, the third statement is true because high recall with low precision indicates the model is finding many relevant items, but is also making many incorrect predictions. Finally, the fourth statement is true because a confusion matrix clearly highlights where predictions are correct and where errors occur, helping identify strengths and areas that need improvement. Question 38. What is the purpose of the description field in the metadata section of a labeling JSON file for custom NER? Select one answer. A. Stores examples of recognized entities. B. Provides a brief text summary describing the labeling project. C. Lists dataset file names included in the project. D. Defines offset length calculations. The correct answer is B. Provides a brief text summary describing the labeling project. With all options reviewed, here's why this field exists. To begin with, the description field is meant to document the purpose and scope of the labeling project in plain text, making it easier for developers and collaborators to understand what the NER project is about. By contrast, entity examples, dataset file names, and offset calculations are defined in other specific sections of the labeling JSON and are not part of the metadata description field. Question 39. A manufacturing company needs to translate technical manuals containing domain-specific terminology that the default model doesn't handle correctly. Which approach should they take? Select one answer. A. Use the default translation API for better general accuracy. B. Create a custom model using the custom translator portal and include their terminology in training data. C. Modify the default model directly by changing system parameters. D. Use the profanity filtering feature to control translation style. The correct answer is B. Create a custom model using the custom translator portal and include their terminology in training data. Now that we've gone through all the options, let's unpack why this approach works best. To start with, technical manuals rely heavily on specialized vocabulary, and the default translation model is designed for general-purpose language rather than industry-specific terms. For that reason, creating a custom model allows the company to train the translator using bilingual datasets that contain their exact terminology, ensuring consistent and accurate translations. In contrast, modifying the default model directly isn't supported, and profanity filtering has nothing to do with terminology accuracy. As a result, a custom translator model is the most reliable way to handle domain-specific language in technical documentation. Question 40. What are two key steps involved in manual synthesis of translations? Select two answers. A. Translate spoken input into text using Translation Recognizer. B. Iterate through the translations dictionary to synthesize audio for each language. C. Attach an event handler for real-time audio output. D. Specify the speech synthesis voice in the translation config. The correct answers are A. Translate spoken input into text using Translation Recognizer, and B. Iterate through the translations dictionary to synthesize audio for each language. Now that all the options are on the table, let's break down how manual synthesis actually works. First, spoken input must be converted into text using the Translation Recognizer because manual synthesis starts from translated text rather than streaming audio output. Next, once the translations are available, you iterate through the translations dictionary and pass each translated text to a speech synthesizer to generate audio for the corresponding language. On the other hand, attaching event handlers and specifying voices in the translation config are part of event-based or automatic synthesis workflows, not the manual approach described here. Question 41. Generative AI models that can process both text and audio inputs provide which key advantage in chat applications? Select one answer. A. They convert all inputs automatically into visual data. B. They eliminate the need for text-based interfaces. C. They restrict interaction to pre-recorded audio only. D. They enable more natural and flexible communication. The correct answer is D. They enable more natural and flexible communication. Now that all the options have been considered, let's connect this to real chat experiences. To begin with, supporting both text and audio allows users to interact in the way that feels most natural at any given moment, whether typing a message or speaking aloud. At the same time, these models do not remove text-based interfaces or limit interaction to recorded audio. Instead, they expand communication options. As a result, multimodal generative AI creates richer, more conversational chat applications that adapt easily to different user preferences and situations. Question 42. A voice agent is deployed to handle live customer calls. Users sometimes speak mid-response, and the current audio continues to play over them, creating a poor experience. You're asked to adjust the client so the agent never talks over the user. Select two answers. A. Stop playback and cancel any ongoing response immediately when server event type.input audio buffer speech score started is received. B. Switch to a synchronous client to ensure responses finish before users can speak. C. Wait for the API to finish processing the interrupt before stopping playback. D. Cancel the current response in the client as soon as user speech is detected, then resume playback only when appropriate. The correct answers are A. Stop playback and cancel any ongoing response immediately when server event type input audio buffer speech started is received. And D, cancel the current response in the client as soon as user speech is detected, then resume playback only when appropriate. With the choices clearly laid out, let's see how this improves the live call experience. To begin with, as soon as user speech is detected, the client must immediately stop playback and cancel the active response, which is exactly what handling the input audio buffer speech started event achieves. At the same time, canceling the response client side ensures the agent does not continue speaking while the interruption is being processed, and playback can safely resume only when it makes sense. By contrast, waiting for the API or forcing synchronous behavior allows audio overlap to continue, which is the core problem here. Taken together, immediate interruption handling and client-side cancellation create a natural, respectful conversation flow where the agent never talks over the user. Question 43. When performing sentiment analysis, which two statements are true? Select two answers. A. All sentences must have the same sentiment as the document. B. A document sentiment cannot be mixed. C. The response includes overall sentiment and sentence-level sentiment for each document. D. Confidence scores show probability values between 0 and 1 for each sentiment category. The correct answers are C. The response includes overall sentiment and sentence-level sentiment for each document. And D. Confidence scores show probability values between 0 and 1 for each sentiment category. Now that we've reviewed every option, let's make sense of what sentiment analysis actually returns. To begin with, sentiment analysis evaluates text at multiple levels, which is why the response includes both an overall document sentiment and individual sentiment results for each sentence. In addition, each sentiment category, such as positive, neutral, or negative, is accompanied by a confidence score between 0 and 1, indicating how strongly the model believes in that classification. On the other hand, documents can absolutely contain mixed sentiment, and sentences within the same document do not need to share the same emotional tone. Taken together, sentence-level results and probability-based confidence scores provide a detailed and nuanced understanding of sentiment in real-world text. Question 44. Which element can help developers determine whether a trained Azure AI language model requires additional improvement? Select one answer. A. Endpoint prefix naming. B. Subscription size. C. Evaluation metrics. D. Azure portal color themes. The correct answer is C. Evaluation metrics. Now that we've reviewed all the choices, let's clarify why this is the deciding factor. To begin with, evaluation metrics provide concrete, measurable insight into how well a model is performing, highlighting areas such as accuracy, precision, recall, or confusion between labels. Because of that, developers can clearly see whether the model needs more training data, better labeling, or additional refinement. By contrast, endpoint naming, subscription size, and portal appearance have no relationship to model quality or performance assessment. As a result, evaluation metrics are the primary tool for deciding when a model is ready for deployment or needs further improvement. Question 45. Which statement correctly describes audio file format options when embedding or linking audio content in a prompt? Select one answer. A. Only MP3 files are valid for all audio inputs. B. Multimodal models can accept multiple audio formats such as MP3 or WAV. C. Audio files must be converted to plain text before submission. D. The model accepts only video files in place of audio. The correct answer is B. Multimodal models can accept multiple audio formats such as MP3 or WAV. With all options reviewed, let's clarify what this means in practice. To begin with, multimodal models are designed to handle audio directly, and they support common formats like MP3 and WAV when audio is embedded or linked through a URL or encoded input. This flexibility allows developers to work with existing audio assets without forcing a single file type. By contrast, audio does not need to be converted to plain text before submission, and the model is not restricted to MP3 files or video-only inputs. As a result, supporting multiple audio formats makes multimodal chat applications more adaptable and easier to integrate with real-world audio data. Question 46. For each Azure AI custom vision component, drag it to its correct description. Used to build and train custom image classification or object detection models. Training resource. Used to generate predictions from new images using a trained model. Prediction resource provides a web interface to manage projects, train, and test models. Custom vision portal. Used by developers to integrate training and prediction in code. Custom vision SDKs. With the correct matches established, let's walk through how these components fit together in practice. To begin with, the training resource is where images and labels are uploaded and models are trained, making it the foundation of any custom vision solution. Next, once a model is trained, the prediction resource takes over by applying that model to new or unseen images to generate predictions. Alongside these resources, the Custom Vision Portal provides a visual, web-based environment where you can manage projects, train models, and test results without writing code. Finally, the Custom Vision SDKs allow developers to bring both training and prediction directly into applications, enabling automation and deeper integration. Together, these components form a complete workflow for building, managing, and deploying custom computer vision solutions in Azure. Question 47. Fill in the blanks by selecting the correct options from the drop-down menus. To start building a custom image classification model, you can sign in to the Custom Vision portal using your Azure credentials, create a project, and connect it to your custom vision resources. Now that we've gone through the full statement and the correct selections, let's walk through how this process works in practice. To begin with, signing in to the Custom Vision portal using your Azure credentials gives you access to your Azure subscription and associated AI resources. Next, creating a project establishes a dedicated workspace where your images, labels, and training iterations are managed. Finally, connecting the project to your Custom Vision resources links it to the underlying training and prediction services that actually build and run the model. Taken together, these steps form the standard starting point for building and managing a custom image classification solution in Azure AI Custom Vision. Question 48. For each statement below, indicate whether the answer is true or false. Object detection models identify both the type and position of objects in an image. Azure Custom Vision requires only one resource for both training and prediction. False. The Python SDK supports both training and prediction. True. Each Custom Vision project has a unique project ID used in client code. True. With the answers clearly identified, let's connect them to how Custom Vision works in practice. To begin with, object detection does more than classification, because it not only recognizes what the object is, but also locates where it appears within the image using bounding boxes. Next, the second statement is false, since Azure Custom Vision uses separate resources for training and prediction, allowing better scalability and separation of workloads. Moving forward, the Python SDK fully supports both training models and running predictions, making it possible to manage the entire workflow programmatically. Finally, every Custom Vision project is assigned a unique project ID, which is required when calling the service from client applications to ensure the correct project is referenced. Question 49. Arrange the steps to leverage the portal's smart labeler effectively. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Label an initial batch of images. Train the model once. Use the smart labeler to suggest regions and classes on new images. Review and adjust suggested boxes or tags, then continue labeling. With the full sequence in place, let's walk through how this works in practice. To start, you label an initial batch of images, so the system has real, human-verified examples to learn from. Once that foundation is in place, you train the model once, enabling it to recognize patterns and object boundaries based on your initial labels. After training, the smart labeler can then suggest regions and classes on new images, significantly speeding up the labeling process. Finally, you review and adjust the suggested boxes or tags to correct any mistakes, and then continue labeling, allowing the model to assist more accurately as the dataset grows. Question 50. For each SDK element, drag it to the appropriate box in the correct match column to match it against the description in the option column. Each item may be used once, more than once, or not at all. Creates an authenticated client for prediction calls. Custom Vision Prediction Client. Holds the API key used to authenticate requests. API Key Service Client Credentials. Submits an image to a published object detection model. Detect image. Wraps raw image bytes for upload to the service. Memory stream file.readAllBytes. Contains the collection of returned predictions. Result.predictions. In a moment, we'll connect each match to what you actually do in code, so the workflow feels obvious. First, Custom Vision Prediction Client is the correct match for creating an authenticated client for prediction calls, because that's the object your app uses to talk to the prediction endpoint and request inference results. Next, API Key Service Client Credentials holds the API key used to authenticate requests, which is exactly what the client attaches, so the service knows your calls are authorized. Then, Detect Image is the method that submits an image to a published object detection model, meaning it sends the image to the trained endpoint and triggers detection. After that, Memory Stream, file readAllBytes, wraps raw image bytes for upload, which is a practical way to read a local file and stream it into the SDK call without manual chunking. Finally, result.predictions contains the return predictions, so when you loop through it in real projects, you can read each tag, probability, and bounding box to draw results on an image or drive downstream logic like quality checks. Question 51. Identify the key labeling difference between image classification and object detection. Select one answer. A. Image classification uses one tag per dataset, while object detection uses no tags. B. Image classification applies tags to the whole image. Object detection applies a tag to each region with a bounding box. C. Both require only numeric IDs and never textual tags. D. Object detection only stores coordinates. Tags are optional and usually omitted. The correct answer is B. Image classification applies tags to the whole image. Object detection applies a tag to each region with a bounding box. Now let me explain this step by step. To begin with, image classification treats the image as a single unit. It looks at the entire picture and decides what labels best describe the image as a whole. For example, a photo containing a cat on a sofa may simply be labeled as cat or animal, without any concern for where the cat appears in the image. On the other hand, object detection focuses on identifying individual items inside the image. Instead of one overall label, the model draws bounding boxes around each object and assigns a tag to every detected region. For instance, the same image could have one box labeled cat and another box labeled sofa. As a result, the key difference lies in how labels are applied. Image classification labels the entire image, whereas object detection labels specific regions using bounding boxes, which clearly makes option B the correct choice. Question 52. Your team needs to automate video indexing and manage custom models programmatically. You're building a backend service, no UI embedding yet. What should you do first to enable authenticated API calls, and what should you use to perform the operations? Select two answers. Use the Video Indexer REST API to create projects, index videos, and manage custom models. B. Rely on widgets only, since they expose all API functions programmatically. C. Call auth, location, accounts, account ID, access token to obtain an access token. D. Trigger indexing solely from the portal. APIs cannot automate it. The correct answers are A. Use the Video Indexer REST API to create projects, index videos, and manage custom models. And C. Call auth, location, accounts, account ID, access token to obtain an access token. Now let me explain how this works clearly. To begin with, Any backend automation must authenticate before making API calls. That is why the very first step is requesting an access token using the authentication endpoint. Without this token, the service will reject all REST requests, making automation impossible. Once authentication is handled, the Video Indexer REST API becomes the main tool for the job. This API allows your backend service to programmatically create projects, upload and index videos, and manage custom models without any UI involvement. Meanwhile, relying only on widgets is not suitable for backend automation because widgets are designed for embedding insights in user interfaces, not for full programmatic control. Likewise, triggering indexing only from the portal defeats the purpose of automation. REST APIs are specifically built to handle these operations from code, which is exactly what a backend service requires. As a result, using the authentication endpoint together with the Video Indexer REST API is the correct and complete approach for this scenario. Question 53. A product support team wants a chat assistant that can answer questions about photos users upload, such as identifying defects from an image and then proposing short text fixes. They will build in Azure AI Foundry. What must they set up to ensure the system can accept and reason over image inputs? Select one answer. Provision a text-only language model and parse images with custom rejects. B. Create a virtual machine scale set to host custom OCR scripts. C. Enable a site-to-site VPN to the data center. D. Deploy a multimodal generative AI model that natively accepts image input. The correct answer is D. Deploy a multimodal generative AI model that natively accepts image input. Now let me explain why this is the required setup. To begin with, if the assistant must understand photos, the model has to be able to process visual data directly. That means you need a multimodal model that can accept an image as part of the prompt and reason about what it contains. In contrast, a text-only model cannot interpret pixels, so rejects or text parsing won't help with image understanding. Likewise, hosting OCR scripts on a VM might extract text from images, but it does not provide general visual reasoning for defects, shapes, or non-text issues. Similarly, a VPN is only networking and does not add image analysis capability to the system. Therefore, deploying a multimodal generative AI model is the essential requirement for accepting and reasoning over image inputs in this scenario. Question 54. Which parameter defines the text description that the DALL-E 3 model uses to determine the image content? Select one answer, AN, B style, C size, D prompt. The correct answer is D prompt. Now I'm going to explain this step by step. To start with, the prompt parameter is the natural language description you write to tell the model what image to generate. It defines the subject, details, and overall idea of the image, which is why it directly determines the image content. In contrast, the N parameter only controls how many images are generated and has no influence on what the image contains. Similarly, the style parameter affects the visual tone, such as natural or vivid, but it does not describe the scene or objects themselves. Likewise, the size parameter only sets the resolution of the output image, not the description used to create it. Therefore, the parameter that defines the text description guiding DALL-E 3's image generation is the prompt. Question 55. Fill in the blanks by selecting the correct options from the drop-down menus. When training a custom model in Azure Document Intelligence Studio, you must upload at least 5 to 6 sample forms to a storage container and provide a linked Azure Document Intelligence or Azure AI Services resource. I'm going to explain how this works step by step. To begin with, Azure Document Intelligence needs real and representative documents to learn from, which is why at least 5 to 6 sample forms are required to capture consistent patterns and variations. Next, those sample forms must be uploaded to a storage container because the training service reads data directly from Azure storage rather than from local files. Finally, you must link an Azure Document Intelligence or Azure AI Services resource, since this resource supplies the compute power, authentication, and endpoint required to run the training process. Therefore, when these three elements are correctly set up together, the studio can securely access the documents, process them, and train a custom model that understands the structure and fields of your documents accurately. Question 56. For each metadata field, drag it to the description that identifies what it represents in an index document. The name or identifier of the stored content item matches metadata, storage name, score, header, storage name. The creator of the original content matches metadata author. The extracted body text of the document matches content. I will now explain the answers. To begin with, metadata storage name refers to the file name or unique identifier assigned to the document when it is stored, which allows the search index to trace each record back to its original source. Next, metadata author captures authorship details embedded in the document's metadata, which is useful when filtering or identifying content by who created it. Finally, the content field represents the full body text extracted during indexing, and this is the primary field the search engine analyzes when responding to user queries. Therefore, these metadata fields work together to ensure documents are searchable, traceable, and meaningful within an indexed search solution. Question 57. A research team uses Azure AI Search to extract images and text from thousands of scanned reports. They need the text for searching and analytics, and they also want to retain each image for later visual analysis. Which configuration supports both requirements? Select one answer. A run multiple indexers separately for text and image fields. B. Enable face table fields in the index schema. C. Export only the index as JSON without a knowledge store. D. Define a knowledge store in the skill set that projects both tables and image files. The correct answer is D. Define a knowledge store in the skill set that projects both tables and image files. Now I'm going to explain how this setup meets both needs. To begin with, Azure AI Search can extract text and enrich content during indexing, but the search index itself is designed mainly for searchable fields, not for storing large extracted artifacts like image files or normalized enrichment tables. Therefore, when the team wants searchable text and also wants to keep extracted images for later analysis, they need a knowledge store because it persists enriched outputs outside the index. Next, by defining a knowledge store in the skill set, you can project structured tables for analytics and also project image files so each extracted image is retained in storage for future visual review. In contrast, exporting only the index as JSON does not preserve image files or structured enrichment outputs. Likewise, enabling face table fields only improves filtering and navigation, but it does not store extracted images. Similarly, running separate indexers is unnecessary here because one pipeline with knowledge store projections can persist both text and image artifacts together. As a result, using a knowledge store with projections for both tables and image files is the configuration that supports both searching and long-term image retention. Question 58. Arrange the REST API analysis workflow in the correct order. Send authenticated posts to endpoint/content understanding analyzers/analyzer. Analyze using a URL or binary. Receive operation ID and operation location in the response. Pull get endpoint/content understanding analyzers/results/operation ID until complete. Parse the final JSON results returned by the results endpoint. Now that we've gone through the question and the correct order, let me walk you through the explanation. To begin with, the workflow always starts by sending an authenticated post request to the analyze endpoint, because this is what actually triggers the analysis job on the service. As a result, the service responds asynchronously rather than immediately returning results. Next, you receive an operation ID along with an operation location. And this is important because it tells you exactly where and how to track the progress of that analysis. In other words, the work has started, but it is not finished yet. After that, you repeatedly poll the results endpoint using the operation ID. Meanwhile, each GET request checks whether processing is complete, ensuring your application weights correctly instead of guessing timing. Finally, once the operation reports completion, you parse the returned JSON payload. At this stage, you can extract the structured fields, insights, or analysis outputs needed by your application, completing the workflow smoothly. Question 59. For each statement below, indicate whether the answer is true or false. Tables with merged cells cannot be extracted. False. Text extraction is performed by all pre-built models, including for handwriting. True. Selection marks such as checkboxes and radio buttons can be extracted by some models. True. Models trained for a specific form type return values for a fixed set of named fields. True. Now let's unpack why each one is marked that way. False applies to the merged cells statement because table extraction can still return rows, columns, and cell data even when a cell spans across multiple columns or rows. In other words, merged formatting does not automatically prevent extraction. True fits the text extraction statement because pre-built models generally include OCR-style text and line extraction as a baseline capability, and that typically covers printed text as well as handwriting, so the document can be interpreted further. True also fits the selection mark statement because certain models can detect choice marks like checked boxes or selected radio buttons, which is especially useful for surveys or forms where a tick mark represents the user's answer. Finally, true matches the form-specific model statement because when a model is designed for a known form type, like invoices or receipts, it returns a consistent set of named fields, such as total, vendor name, or invoice date, making downstream processing predictable. Question 60. Which capability enables Azure AI Search to provide insights such as key phrases, detected entities, and extracted text from images? Select one answer. A. AI enrichment. B. Data ingestion. C. Query filtering. D. Data warehousing. The correct answer is AI enrichment. Now let me explain how this works in a clear and connected way. To begin with, AI enrichment is the capability that integrates AI skills like OCR, key phrase extraction, and entity recognition directly into the indexing pipeline. As a result, raw documents and images are transformed into enriched, searchable content that includes insights beyond basic text storage. On the other hand, data ingestion simply moves raw data into the search service without adding intelligence, so it cannot generate insights. Meanwhile, query filtering only helps narrow down search results after indexing and does not extract information during indexing. Finally, data warehousing focuses on storing structured data for analytics, not on enriching content with AI-generated insights. Therefore, AI enrichment is the capability that enables Azure AI Search to extract text from images and identify meaningful information like entities and key phrases, making search results far more powerful and insightful.